So today we are going to study about the preparation of aryl halides. Preparation of aryl halides. Aryl halides. First one, when toluene is the next homologue of benzene. When toluene is treated with the chlorine in presence of any Lewis acids like FeCl3 as catalyst, in presence and in sunlight and in darkness, this happens in presence of darkness. So when toluene is treated with the chlorine in presence of a Lewis acid in dark, what happens is the substitution, electrophilic substitution takes place at the ortho and para positions because this is an electron releasing group. So at the ortho and para position, the substitution will take place. You will get orthochlorotoluene and parachlorotoluene. A mixture of ortho and parachlorotoluene is formed. So you will get a mixture of ortho and parachlorotoluene. So it must be, toluene is to be mixed with the chlorine in presence of any Lewis acid catalyst and in dark. And what happens is, at the ortho and para positions, the substitution will take place because methyl group or any alkyl group is an electron releasing group. You will get a mixture of ortho and parachlorotoluene. And how this mixture is separated? It is separated by distillation because there is a large difference in boiling point between these two. So since there is a large difference in boiling point, we can use either fractional distillation for the separating this mixture. Now if this same toluene, if you treat with the chlorine in sunlight, can you tell me what happens? If it is treated with the chlorine in presence of sunlight, last year we have studied free radicals, substitution of hydrogen will take place. You will get benzyl chloride, CH2Cl. The substitution will take place at the side chain. Here, understood? The hydrogen will be substituted by chlorine if you are treating with the chlorine in sunlight. So there is a difference in product. If you treat with the chlorine in presence of a Lewis acid and in dark, ortho and para substitution will take place. Whereas if you treat it with the chlorine in sunlight, the substitution and the side chain will take place. You will get benzyl chloride. So this is one method of preparation of, and this is not considered as an aryl halide. This is benzyl halide. It is not an aryl halide. Now next is the another preparation. It is a name reaction. The name reaction is called the Sand-Meyers reaction. Sand-Meyers reaction. You have your memory card with you. So add Sand-Meyers reaction. This reaction to the. In Sand-Meyers reaction, what we use is benzene diazonium salt. Benzene diazonium salt is this one. Benzene, then N2Cl. This is benzene diazonium chloride. This is obtained from benzene. Aniline, a aromatic primary amine. Aniline is diacetized. How it is diacetized? It is treated with the sodium nitrite and HCl. Sodium nitrite and HCl. And the temperature range must be 273 to 277 Kelvin temperature. 273 to 277 Kelvin temperature, that is the temperature must be below 4 degrees Celsius. So you will have to cool it in ice. Then when aniline or the aromatic primary amine is treated with the sodium nitrite and HCl and the temperature range, if it is 273 to 277 Kelvin temperature, diacetization reaction will take place and you will get benzene diazonium chloride. This chloride, if you treat with the copper 1 chloride and HCl, you will get chlorobenzene. You will get chlorobenzene. And if it is treated with the Cu2, Br2 and HBr, that is copper 1 bromide and HBr, you will get a bromobenzene. You will get a bromobenzene. Understood? So, Sandwich reaction starts only from here. This is another reaction. So, benzene diazonium chloride, when it is treated with the copper 1 chloride and HCl, you will get a chlorobenzene. Copper 1 bromide and HBr, you will get bromobenzene. Understood? So, this is another method. This is a name reaction. Add to your memory card the Sandmeyer's reaction. This is the first name reaction, Sandmeyer's reaction. But we cannot prepare iodobenzene by this method. Iodobenzene you cannot prepare by this method. And fluorobenzene also we cannot prepare because fluorine is a very highly reactive substance, so we cannot use fluorobenzene also. Then another method we will not use. Again, diazonium chloride N2Cl, it is treated with the potassium iodide. When it is treated with the potassium iodide, you will get iodobenzene. So, the copper 1 chloride you will not get. So, this is another method. So, when this is not Sandmeyer's reaction also. Sandmeyer's reaction finished there. This is another reaction. Understood? When you treat it with the benzene diazonium chloride is treated with the potassium iodide, you will get iodobenzene. This is not included in Sandmeyer's reaction. So, benzene diazonium chloride you can convert to chlorobenzene, bromobenzene or iodobenzene. So, these are the methods of preparation. Now, next is of aryl halides. We will go back to alkyl halides or haloalkenes. Next method is from alkene. That also you have studied last year as a property of alkene, chemical property of alkene. Alkenes, since they have a multiple bond, they undergo addition reaction. Addition of hydrogen halides, CH2, double bond CH2 plus HI or HBr or HCl any. You will get CH3, CH2I. You will get iodoethane. This is addition of hydrogen halide. This is a symmetrical alkene. If an unsymmetrical alkene is there, CH3, CH, double bond CH2. This is an unsymmetrical alkene. If you add HBr, there are two possibilities of two, isn't it? Which are the two products? Yes, last year we have studied. This is the possible products are either bromine can be added here and hydrogen here, or bromine here and hydrogen here. So you will get CH3, CH2, double bond CH2Br, sorry, single bond CH2Br, then CH3, CHBr, CH3. These are the two possibilities. Either bromine is added here or here. You will get two possibilities. Out of that, the major product is the second product. Why? The addition takes place according to Markovnikov's rule. According to Markovnikov's rule, the negative part of the addendum, here bromine Br is the negative part of the addendum, it will go to the less hydrogenated carbon atom, and the positive part of the addendum go to the highly hydrogenated carbon atom. So you will get this as the major product. And if you are using peroxide as a catalyst, and according to peroxide if you are using, this will be the major product. The Br will get added to the next, that is anti-Markovnikov's rule. So if it is in the absence of peroxide, you will get this as the major product, and in the presence of peroxide, this is the major product. This is Markovnikov's rule. So that last year we have studied. And if you are adding a bromine molecule, what will you get? CH, double bond CH2Br. sorry, CH2, you will get plus Br2. Bromine also you can add. What will you get? Bromine molecule if you add, you will get CH3, CH3, CHBr, CH2Br, right? They are called vicinal dihalides. You will get a vicinal dihalide because the two halogens are the nearer carbon atoms. So we call them vicinal dihalides. If you add bromine, you will get a vicinal dihalide. Last year you studied these reactions. So this is another method for the preparation of alkyl halide from alkenes. So this is from alkene. Now some haloalkanes can be converted to other by some reaction. For example, CH3 X can be either chloro or bromo derivative. If it is treated with the sodium iodide in dry acetone, the reaction takes place. What is acetone? Acetone, it is propanol. Acetone is propanol. CH3, CO, CH3. The common name of propanol is acetone. In dry acetone, if you do this reaction, you will get a CH3I, iodomethane, plus NaX. NaX get precipitated in dry acetone and you will get methyl iodide. And this reaction is a name reaction. It is called Finkelstein reaction. Finkelstein reaction. And according to this reaction, anidoalkane is prepared from chloro or bromo by treating with a sodium iodide in dry ether. That is called a Finkelstein reaction. And you can prepare fluoroalkane. When you treat with the CH3X, either again X can be either chloro or bromo. When it is treated with some metallic fluorides like the silver fluoride or mercury fluoride, etc., AgF. If you treat, you will get CH3F, F plus AgI, AgX. AgX can be preferred. So you will get fluorobenzene. This is another name reaction. It is called a Schwarz reaction. Schwarz reaction. So Finkelstein reaction and Schwarz reaction. Again, two name reactions. You can add to your memory card. So Finkelstein reaction is for the preparation of iodobenzene and Schwarz reaction is for the preparation of fluorobenzene. Okay. So these are the preparations. How you can prepare haloalkenes and haloarenes.